all for joining me as I talk about evaluating text extraction at scale with Apache Tika. So first, a little bit about me. I'm currently a data scientist at the Jet Propulsion Laboratory at Caltech. I'm also the chair VP of Apache Tika and a committer on PDFbox, POI, Lucene Solar, OpenNLP, and I'm a member of the Apache Software Foundation. I'm thrilled to be here speaking with folks in industry. I very much appreciate Francois Fernandez's talk on open source, and I see some areas for collaboration between open source and industry. I think Duff's point about PDF association raising all boats is really important for us on open source, and I think if we all can work together, I can certainly see that with collaboration with industry. All right, so this work, the more recent versions of the work on this task has been funded by DARPA under the SafeDocs program. So note the little disclaimer at the bottom of the About Me slide. All right, so the talk is organized. I'll start with an overview of Apache Tika. I'll talk about what can possibly go wrong, and as aficionados of PDFs, I hope you all get a chuckle about that one. I'll talk a little bit about the tika-eval module, offer some brief introduction to that. Then I'll talk about taking that module and scaling it out on public Corpora. All right, so for those new to Apache Tika, it's an open source Apache 2.0 licensed toolkit for file type detection and then applying the appropriate parser. The goal is to have uniform input and output, so you send bytes to Tika and you'll get hopefully uniform output. We try to normalize metadata across the parsers, take a lot of the parser-specific idiosyncrasies out of the hands of the developer so they don't have to worry about that kind of stuff. It's fairly easy to add new types for file type detection. You can add new parsers. I've seen people wrap commercial parsers in Tika because it is a useful framework that's used across the US federal government and in industry, in open source project and in commercial projects. One of the fun things is that it works recursively to handle embedded files and attachments, and I'll talk a little bit about that. And we also have an integration with Tesseract OCR, but one could fairly easily add integration with other OCR packages. So what sold me on Tika and what made me finally drink the Tika Kool-Aid was I was in a place where I was processing files, and we had a couple of handfuls of different types of files. And everything was fine and dandy until I realized that if I did file type detection and then applied my parser, I would still be missing all of the attachments. I didn't have, when I was cobbling this stuff together in the mid-2000s, I didn't really have this framework to do file type detection on embedded files. And one of my early tasks that relied on Tika was to take, people were filling out reports in MS Word files, attaching them into PDFs, and then sending them as mail files. So we would get MSG files and have to pull out the PDFs and all of that. So using Tika to handle those embedded files was really important. And this is an example where we have an embedded zip file inside of an embedded zip file inside of a Word file. And the output looks something like this, where you have a list of metadata objects, including the content, so that you maintain all of the metadata from all of the internal files, which can be extremely useful. All right, so we have a little UI. It's a toy pretty much, but this shows you what you can get from this PDF, which was saved, an HTML file that was saved as PDF. You drop it in, you can get metadata out. It'll pull out the XMP or the PDDoc info, or you can see it as text, as the text that's extracted, or you can get a combination in this JSON format where you have the metadata and the content. Now for the fun part, what could possibly go wrong? Well, as you know, parsers occasionally get upset and they throw exceptions. That can be the fault of the parser, it could be a fault of corrupt files, could be a combination of those two. For PDFs especially, the files may be image only, so you may need to have a mechanism to determine when to run OCR. It could be password protected files, could be file types that aren't covered by your system. There are also, on the other hand, some catastrophic things that happen, and that's when you have infinite loops or out of memory errors or seg faults, obviously security compromises are rather catastrophic. All of these things are kind of high-level categories of the things that we all know about, and they announce themselves pretty loudly when they happen. But what can subtly go wrong? And that's where things get a little more interesting. Well, you can have missing text, obviously, and if it's an image-only PDF, that's pretty obvious. fairly obvious. Missing attachments, if the software fails to pull out the attachments, can be a problem. And garbled text, and especially with PDFs, that can be a major issue. So I'll talk a little bit about, or I'll spend the next couple of slides, or a fair amount of time in this talk talking about garbled text going forward. So this is an example of missing text. This was an actual file that was submitted to Apache Tika's bug tracker. The file on the left, it was a docx file, was the text that was in the file, and the text on the right was the text that we were actually Tika was pulling out at that time. And when you look at this example, it's not that big of a deal. We missed some text, but this poor Jane Cody isn't going to get a job if they're relying on NLP stuff to pull out the keywords and all that other stuff. If we're only getting out that much text, so that's one major thing that can go wrong. Garbled text is another big one, of course. And here we have an example when we upgraded in Tika to Apache PDFbox 187. So this is many years ago now. And in 186, we were getting some pretty good text. In 187, we were not getting good text. And this was around the time that I started working with the PDFbox community. So based on some of that, I wanted to normalize and regularize evaluations so that when Tika was making that choice to upgrade from one parser to a later version, to a more recent version, that we would catch those kinds of things. And ideally push that further back the stack so that we could catch those before the release of the next version. And since I got tika-eval out and have been working with PDFbox and Apache Poi, the Microsoft Office and open source Microsoft Office parser, we've been getting both PDFbox and Poi to run these processes to identify potential regressions before the release, which is the way it should be. So we have this module in Tika called tika-eval, and it's a library and command line tool to calculate a number of statistics. And at this point, it runs in two modes. It runs in profile mode, which is where you run Tika on a batch of files. It'll output the extracts into an extract directory. And profile will run through those extracts and tell you how many exceptions you had, what kind of exceptions they were, what it'll do, language identification, and I'll talk a little bit about some of the other statistics it'll pull out about the quality of text that it's extracted. We also have this compare mode where you run two different tools on the same batch of files, and this will run through and compare pairwise for each file and give you the same statistics as profile, but then it will also give you measures of textual overlap. So how many words did the text extracted by the two different tools, how much does that text have overlap? And it will also give you some other comparisons, and I'll talk in some more detail about those in the next slide. What is coming soon and kind of in the works is something called multi-compare, and that's where you can run multiple tools and get a sense of how different the text extracted is across those multiple tools. That's not ready for prime time. It's not into Tika yet, but that's coming in hopefully in the next couple of months or so. All right, so a slightly deeper dive into some of the common text stats that are pulled out in profile mode and also in compare mode. So one is simply number of tokens, number of unique tokens, alphabetic tokens. Language ID, we run a modification of OpenNLP's language identifier, which can identify, I think, 120 languages. If you have enough text, it's quite reliable. Token entropy, which gives you some sense of how noisy or how repetitive text is. Unicode code blocks, so you can get a sense of how much diversity there is in Unicode characters that are being pulled out. And then, excuse me, what I'd like to focus a little bit on is this common words and out of vocabulary statistic. So this was a statistic that I developed in collaboration with Tillman Hauscher of the PDFbox. And we started with English, and what we did initially was just take the first 30,000 most common words from English from Wikipedia. So I downloaded a Wikipedia dump for English, took the top 30,000 words, and then we compared for a given text how many of these words that we pulled out for a given file were among the common words. So you can have a percentage of the words that we pulled out that were common words, or the inverse of that, which is the out of vocabulary. So if you have a file with a lot of out of vocabulary words, that could mean that something went wrong in text extraction. if you're only running in profile mode. Now, there are admittedly good reasons and edge cases why you could get plenty of, you could get a file without a vocabulary words if it's not a natural text file. If it's, I think in USDA context, we ran into duck file, so it was just a list of various types of ducks, or part numbers, or spreadsheet kinds of things that aren't natural language. So in profile mode, you will find these files that aren't really meant to be, that aren't, even if text extraction works perfectly, it's not normal language, so you expect a high out of vocabulary. But if your assumption is that generally your documents have language in them, natural language, then this out of vocabulary statistic can be extremely useful. And I'll show you a little bit, we'll do further examples coming up in the next slides. All right. So here's an example where we were running regression tests against before the release of Tika 115. This is text pulled out from the same file. So in 114, we pulled out 1,600 tokens. The language ID was Chinese. I can't read Chinese, but you can see the top end tokens. If you can't read Chinese, look like Chinese. Apparently, if you can read Chinese, this looks like complete junk. It's not; those are not Chinese not Chinese words. With 115, after we made a small modification to encoding detection, we're starting to get German. And I know a little bit of German, and that's actually, you can tell at least from the words that that's German. So you can tell that just a little change in the parser can lead to substantially different text being pulled out of that file. And the other thing is that now we're moving from an out of vocabulary measure of 100% down to 54%. And 54% is, kind of within the bounds of a regular natural language text. So this is, and you can see the overlap between these two extracts was 0%, and the increase in common words was 116. So the point is that with automatic means, you can get some insight that you're doing a better job. And in this case, we're doing a dramatically better job for this file. This file shows a slight regression where we're losing some common words. We're going from an out of vocabulary of 44% up to 45%. And you can see from the top 10 unique tokens that we're messing up something with an apostrophe. That apostrophe is turning into an S for some reason, or something else is going on. Maybe, yeah. So something has gone wrong with this parser on this file slightly. But the key thing is that with tika-eval, we now had a method to identify differences between parsers so that we could manually review some of the changes to see if it's a systemic change that we need to fix, if it's a dramatic issue or not. And this is the third kind of thing one can do with this. So we saw improvements, we saw regressions, and that's on the per file level. But the other thing one can do is look across the corpus. Are we doing better or worse for a given file set, for a given language, for a number of different things? In this table is extraordinarily eye-opening. Here we're comparing the difference between the default HTML encoding detection, which effectively just looks for the meta header in the HTML file. It's when the HTML file says, I'm UTF-8, and then we apply that character set versus Mozila's universal car set encoding detector, which does statistical analysis of the bytes to figure out what the encoding is. And you can see for some of these files, or across the corpus, and I think this was on a subset of Common Crawl, when the HTML header said I'm UTF-8, but universal car set detector said no, it's a UCJP, you can see a dramatic increase in number of common tokens when we relied on the universal car set detector versus when we relied on what the HTML page was saying about itself. So we haven't yet folded this into Tika, so users still have to pick which car set detector they're using. But the goal eventually is to fold this kind of analysis into the processing during parse time, so that we can try out different encodings in this case and see which one gets us better results, and then parse the file as that. Right now, the tika-eval stats are kind of used post hoc, still extraordinarily useful, but the goal is to push that further down the stack into processing. All right. This is an example of looking at the out of vocabulary percentage across a handful or a couple of handfuls of English PDFs, and you can see some are, a couple of them are way out of line, and when you actually look at that text, it is completely garbled. This is an example of a publicly available JPL document. Looks fine to a human, but you can see the text as it's stored in the file is complete junk. When you run Tesseract on that file, you get pretty good text. It's not perfect, but it's much better than the junk you were getting. So the point of this is that you can use this stuff for developing parsers, for finding regressions in parsers, but also potentially in workflow. If you pull the text out of a PDF, you get a high out of vocabulary statistic. You can then choose to run OCR on that and see if you're doing a better job with OCR. And of course, so we came to this through trial and error and in conversation with Tillman and some other colleagues. And then after we came up with our method for English and expanded it to, I think, about 120 languages, we found that I'm sorry. We found other people were doing something similar. So here's this file in Google's cache. You can see that they are clearly running OCR on it. I then found this paper from 2009 called the Panlingual Anomalous Text Detector, which is a fantastic paper. It turns out that we have effectively implemented their strawman approach, which I found humorous. They have a method that's more that does a better job, but to my mind only slightly, and it requires a fair amount more processing, and it requires page locations, which we don't have for all of our files. PDFs, obviously we do, but not for other file types. And of course, this author is at Google. So I feel like we're on the right track, that we have re-implemented just 7 years later when I first started this, something that Google was already publishing, but it is extraordinarily useful, and hopefully we can get out these techniques and share these techniques with commercial organizations to try to improve this across open source tools and for commercial entities. All right. Yeah, so as I mentioned, this stuff is really useful for parser developers, especially when you're starting with a new parser, with new file format, new parser for that, but also just before you make a release to make sure that you don't have any major regressions. In production, I'm trying to push some of the stuff into production so that you can figure out which parsers to use. So, are we doing a better job with PDF to text, or with Apache PDF Box, or with a commercial option for this given PDF? Which one do we want to take the text from or use for our index? Which encoding detector to trust, and I showed that example. When to run OCR, and even from a search engine perspective, if you get files with a bunch of junk in there, you might want to deboost the relevance for those documents, or do other things in your index, recognizing that you're probably getting junk for this file. All right, so some other indicators that we've run with in addition to, and made some use of, in addition to out of vocabulary, have been low token to page ratio, and those could just be PDFs with images in them. If you're getting Catalan as the language identification, but you think you have English, something's probably gone wrong. Mean and median word length and standard deviation of word length. If your average English, if your document is in English and your average word length is 12, something's gone wrong, or 1, something's gone wrong. Unicode code blocks, alphabetic, non-alphabetic, and those things. So those are other indicators. They're not perfect, but in the absence of ground truth, they at least allow humans to go back and do random sampling to get a sense of how big that problem actually is and what the causes of some of those indicators can be. All right, so in the absence of ground truth, there are obviously lots of limitations. One is, when I first started this, I thought, well, we'll have the dashboard and we'll just do all this automated processing, but it's useless, or it's not as meaningful as one would want it to be. So let's say we're getting more exceptions. We think, oh, that's a problem, but no, it might be you have a new parser and you were just skipping those files before. Or it could be that the parser that used to be yielding junk is now throwing an exception. So that's better because it's at least notifying you that there was a problem. Or fewer exceptions. Well, again, you think you're doing great, but no, you could be skipping files because your MIME detection has started to fail, or now you're getting junk. So you're actually subtly really wrecking your workflow. This goes for everything, more common words, fewer common words. There's always a good reason why you may actually be having an improvement in your processing pipeline if you see these things. So the key thing from my perspective is that a human still has to review the results, do some random sampling to get a sense of the causes of these issues. All right, so here is just a quick view of what multi-compare will look like, or pieces of multi-compare. So here I was fuzzing some really simple PDF files to see if I could get different text pulled out from different tools. So I ran mutool 117, PDF to text 062, different fork of PDF to text. The older one, 303, 2 different versions of Tika. And by scrambling some bits in the PDF with a PDF-aware fuzzer, I was able to get 4 different sets of text from this one file. So for file 1, You can see set 0, so mutual 117 agreed with Tika 110, and it just returned 0 bytes. But set 1 gave me Hull World. I got Hull World for set 2 and Holly World for set 3. So this is a really handy way of looking across parsers, a number of parsers, to see what kind of overlap you're getting for those different parsers. All right, so then we took tika-eval public. So we were running it before regression testing, or we were doing it before we would release the parsers. We started more collaboration with Apache PDFbox and Apache POI to run those evals as part of the release. But then we also pushed further, and we wanted to have a common set of documents that we could share with the world. So Marwan Sayoun, who's a committer on PDFbox, generously offered a VM for us. So we now have roughly a terabyte of files from GovDocs1, Common Crawl, and some bug trackers. And I'll talk about these files a little bit later. We are hosting them. You can download them. We're just starting to make it mildly easy for you to find the file types you want via dataset if you can do SQL. And I've just recently tweeted out something about how to find, I think one of my friends wanted docx files, so I tweeted out how to do that, 2 different ways of doing that. It still requires SQL, and it still requires you to understand the table structure, but we're getting there. We're hoping to make it easier for people to find types of files that they need to find for their processes. What's been really critical about this is we went from, I think when I started this, we had, I think, less than 1,000 files in our unit tests. And this just, blows that. The great thing about unit tests, and I'm not saying you shouldn't have unit tests, is that you know exactly what you expect to find in the file, and you include that file for specific reasons. In addition to that kind of testing, this large-scale regression testing reveals lots of things because so many different things can go wrong in a PDF file especially, but in other file formats too, that running against a large batch of documents reveals a lot more than one can do simply through unit tests. So it's kind of a valuable complementary way of testing. Yeah, so the other thing it helps with is we often get these people asking for help on either on Stack Overflow or on our mailing list saying, I can't share the file with you, but I'm getting the stack trace. Well, now we can do a little bit of SQL and see if we can find that stack trace in our public regression corpus. And if so, we can then use that publicly available file as a way to develop and fix that bug. So it's a really handy way of being able to talk about potentially sensitive documents that are triggering a specific stack trace and finding one that's not sensitive so that we can fix it. So that's been another valuable use of this regression of these corpora. So GovDocs1, I have some links here for you. Common Crawl is a fantastic resource. I encourage you to read Peter Wyatt's article, a recent article on a new stressful PDF corpus on bug trackers. He makes reference to some work some colleagues and I did at JPL on Common Crawl. It's an amazing resource, has some limitations, but you can get a lot of files very quickly. All right, and this is what the corpora looks like, just individual files, folders. In bug trackers, what we've done is, based on Peter Wyatt's recommendation, we went out and crawled Bugzilla, Jira, and I think GitHub and a couple of others types of bug crawlers for common open source parsers, so that when people are attaching files saying that here's a problem, we'd download that and make those files available. We've also packaged up the PDFs and zipped them all up so that you can grab those under something. I can't remember what it is, but I can share it with you if you have an interest in that. So that's what our bug tracker corpus at a high level looks like. We look forward to continuing to improve that and keep that up to date. I think we ran it back in February, maybe March or something like that. So we're hoping to keep that up to date and also keep the metadata about those files more up to date. Anyway, so those are some publicly available resources. So please join the fun. This is open source. We have our website at top. We have our wiki. If you have an interest in participating in corpus curation, corpus gathering, please join the Corpora dev list, email list with Apache Tika. And obviously we have our issue tracker, and we even have our own Twitter account. So please follow that if you have an interest in anything we're doing. Now it is time, I think I've nailed the time, yes, just about, for questions.
Yep, thank you, Tim. Okay, we'd like to take some questions for Tim through regarding his presentation. As a reminder, you can still submit questions through the questions pane in your control panel. Tim, over to you.
Great, thank you. So, so far, one question is, how does Tika handle engineering level math? Math source is usually LaTeX or MS Word. Not well, to be fair. For MS Word, we try to pull out what we can, but we're not doing anything equivalent to what commercial tools are doing that have focused on those formulas, on engineering types of math representations. Our committers are standing by, though, if you have any improvements you'd like to make to pulling those out. All right. Looks like that is the only question so far. Are there any other questions?
So what's the next step, Tim? Where are you planning to take it from here?
Sure. So thank you, Doc. There are a couple of areas. One is we hope to continue to develop those relationships with larger communities for building out that corpus so that we have better representations of the kinds of documents that people care about. So certainly tending to that corpus, making it more accessible, making it more searchable, making it easier for people to access. That's one area where we intend to make improvements. Anything else that we can do to improve that anomaly detection, detection of junk text, comparison between quality of text from OCR or otherwise extracted text is also useful. So if anybody would be willing to share or collaborate with us on new measures for evaluating content extraction, we would be thrilled to do that. And so those are kind of two main areas. And then obviously within Tika, within the main body of Tika, we are coming up with Tika 2.0 is coming out hopefully in the next couple of months, which I've been saying for roughly 2 years. But I mean it this time, I think. And that the goal of that is to modularize the parsers much more carefully so that if somebody really only wants Office type files, you know, MS Office, PDF, and so on, and I know PDF is a lot more than Office files, I got that. But if they only want a subset of parsers, they don't have to bring in the huge, you know, 80 meg jar file. So that is a major undertaking to do the refactoring there. So that's the kind of the third main area for areas for improvement.